Our next speaker is Justin Hiemstra, currently with the Pelican team, but not for very long. You can ask him about that on the break, I'm sure. He's going to talk to you about some new backends we've added to the for standing up Pelican Origins.
All right. Good afternoon, everybody. Hopefully everyone had a good lunch. Interesting to note, my first ever HTC week presentation was a Wednesday right after lunch, and it looks like my last one for the time being, at least, will be as well. So for those of you who don't know me, I am one of the software engineers who works on the Pelican platform. And today I wanted to talk to everyone a little bit about some of the work we've been doing in the Origin component of the Pelican. But before I talk about what we've been doing and some of the new backends we've been trying to support, I wanted to start by just framing things as what is Pelican here to accomplish? So if you go to our documentation website, you'll land on a page that has some of these aspirational, lofty sounding goals of the hand-wavy funding buzzwords of what are we here to do. And I think a lot of these are good to keep in mind. But there are two of them that I think really establish a contract with the users of the experience we are trying to provide for people. Those two are enabling access to data wherever that data lives and wherever it needs to be computed on. And then the second is to coalesce data from disparate object repositories, and I'll talk a little bit more about what I mean by object repository. So regardless of what that storage technology is, to coalesce that data under a common namespace. So in the OSDF, this is the namespace path that you use to access your objects. So a lot of the magic for this stuff happens in the Pelican Origin component. And most of the work I've done in Pelican has maybe been more in some of the central services, and I won't talk as much about all of the Pelican components. So if I had to pick a favorite child, it would probably be the director component. But if I had to pick a second favorite child, it would be the Origin, because the Origin plays a really loaded role, and it does a lot of really interesting things. And the Origin, I think, is maybe one of the hardest things in Pelican to get right because of the role it has to play. So first, the Origin serves as a translator. I'll talk a little bit about the different protocol domains that Pelican uses and how the Origin facilitates translation of all the different things we have to do to get your data from one place to another as we cross those protocol boundaries. But the Origin's first and most important job is that of translation. How do we get the stuff out of the object repository and into all of this stuff that I've drawn a red box around, which is the kind of Pelican Federation box? The second thing that the Origin is in charge of doing is implementing all of the different authorization policies that you, as the owner of this object repository, might want in place. So you maybe have certain rules about who's allowed to access your data, the ways in which they're allowed to access that data, revoking tokens, setting up access policies, all of that kind of stuff. That is the domain of the Origin. There are also some circuit breaker duties that are built into the Origin. So one of the things that we generally say is this object repository, which is kind of the place that all of your data lives, is a fragile, maybe slow, maybe expensive resource to go talk to. So whenever possible, we want to avoid having to go and pull data directly out of the object repository. But one of the things we're most concerned with is hooking up a fleet of clients to something like HT Condor, which is a really, really good DDoS machine. And so the Origin here has the role of kind of being the good friend who will fall on the grenade to protect the object repository from blowing up, melting down, or otherwise having lots of problems. So the Origin is supposed to act as that circuit breaker. It's supposed to pop and protect the object repository before any of the bad stuff can happen there. The fourth thing is that the Origin is kind of the Federation administrator's window into the health of the actual object repository and the ability to work with the data that lives there. So the Origin needs to have some sense of, is the object repository functioning? Am I able to connect to it? Am I able to do the things that I am supposed to do to facilitate the transfer of data in and out of the object repository? And one of the things that makes working with Origins difficult, because we want to support a number of different backends, whether it's POSIX, S3, Globus, et cetera, is that doing all of these different things is kind of bespoke and unique to each different type of backend. So when we want to create new backends for the Pelican Origin, we have to think about all these things and what it means to do each of these for the particular storage technology we're targeting. Okay, so I mentioned that origins act as translators. What do I mean by that? For those of you who have actually used Pelican to get or put or stat or list data, you've probably worked with one of these Pelican URLs. And for those of you who drink a lot of Mountain Dew, you'll know that the beginning of this URL starts with Pelican : // What is that thing? In a URL, that is how you define the protocol that that URL is meant to work with. So Pelican has defined the Pelican protocol, and that is the piece of a Pelican federation that deals with object discovery. Where do I go to find an object? How do I figure out what authorization policy I need to work with? How do I get a token if I need a token to go get or write to an origin? This is all in the Pelican domain. So when we're talking Pelican protocol, we're usually going off to central services like the registry and the director and asking all of these types of questions. But at some point, the director is going to tell us, now it's time for you to actually go talk to the source of this object, whether that's an origin or a cache. The object lives somewhere, and now you have to actually go get it. So this is the point at which this translation step really kicks in. So I'm skipping caching for now. Generally, Pelican client would be directed to a cache. In this case, we're going straight to an origin. So Pelican under its hood uses a software stack called xrootd. And xrootd is the data delivery mechanism that Pelican sits on top of. I like to think of Pelican as an orchestrator for xrootd. We kind of operate a metadata layer on top of xrootd, but xrootd is the thing that's actually responsible for shoveling out bytes of data when you go and ask for it. So we show up to the origin. We're kind of speaking the Pelican protocol via HTTP at this point. But then we get into this giant sausage-making factory. So we show up to xrootd speaking HTTP. That HTTP request is immediately converted into an xroot protocol request, which then bubbles down through various layers of protocol translations until finally everything has been translated and we're spit out on the other end speaking whatever protocol is the native protocol for the object repository that we want to talk to. So in this case, we came in speaking Pelican HTTP, and on the other side, we come out speaking Globus HTTP. And so by doing this, the origin is able to work with the object repository in its native protocol and translate all of the different operations we want to do back into something the rest of the federation can understand. So I put together a big table of all of the different translations that we support. This is not something I hope any of you look at and try to memorize or really even stare at too closely. The point of this is more or less to say that we have these verbs over here. These are the Pelican verbs, the things that you can do using a Pelican client. And whenever we want to come and put together a new Pelican Origin backend, we basically have to take the exercise of filling out this table. So it's a pretty straightforward thing to do. We've got experience doing it, and we continue to work on new Origin backends filling out this table. All right, so this is great. We have a translator. It's a layer of abstraction. It's going to solve all of our problems, right? We can connect to any storage backend, and everything's going to be seamless, yeah? No. Okay, so this is where I have to put in my obligatory Shakespeare quote. There are more things in heaven and earth, Justin, than are dreamt of in your philosophy. What do I mean by that? Well, first, it would be great if we had a really well-defined philosophy for Pelican. Oh, sorry about that. Having the Pelican philosophy of what do we mean by objects? What are object repositories? What are the verbs? What are the semantics of... All right. Yeah. This is the shepherd's hook pulling me off. All I need is a laptop to finish this in the basement, just saying. Yeah. All right, keep going. All right, so I think it would be good for Pelican to have a stronger philosophy about these different things, because we keep coming into points of friction working with users. What is immutability? What can we support? What can't we support? But even assuming that we had a really, really good and well thought out philosophy, The problem is that philosophies between all of these different origin backends just don't always translate cleanly. So a few examples of things that we run into already that cause problems. The first here is Pelican supports hierarchical namespaces. So you create a parent namespace, you can subdivide that, you can give authorization to collaborators or sub-projects. That's hierarchical. Something like S3 that we support doesn't really have any hierarchy in its object names. S3 uses flat buckets, and you can kind of string together something that look like directories in S3, but it's a hack. This other example with something like POSIX, which allows partial file writes, that doesn't really carry over to Pelican, which uses a more atomic whole object put model. So there are places where even having a good philosophy, we can't necessarily translate everything from the object repository's protocol and the things it supports into Pelican. And that can lead to points of friction when developing new origins. Next, so we've translated protocols, and maybe this is a part of the protocol because object repositories will have their own specific authorization protocol, but this is another piece that Pelican has to deal with. So I'll take just a second. I think Brian A. is talking more about authorization, and maybe he'll cover some of this. But inside the Pelican layer of things, inside this Pelican protocol, we come in with a JSON web token, so a WLCG or a SCI token, and we hand that to the origin, who picks it up, looks at it, and makes a decision. Am I going to let you have the piece of data that you're asking for, or to write the piece of data that you're asking to write? The origin picks up that token, gives you a yes or a no, and at that point, the origin now has to pick up something else. It picks up some object repository specific piece of authorization. It may also be a token, it may be something else, but it then uses this object repository specific piece of authorization to actually go talk to the object repository. So there's authorization translation that happens as well. And then I think this is one of the most interesting things that Pelican is working on and maybe has some work to do, is translating the kind of squishier, softer, more natural language type policies that the object repository provides to the origin about how it wants to be accessed, in what ways it's okay being used, what types of things it's willing to support, etc. So you can imagine, I said that the origin's job is to sacrifice itself to protect the object repository. So that suggests something like throttling. How does the object repository tell the origin what throttling means? Or maybe the object repository is an AWS S3 instance that charges you 10 cents for every byte you move. How does the object repository tell the origin what the maximum cost it's willing to incur? Maybe the object repository has auditing requirements. If you're going to come and ask me for a piece of data, I want to know who asked that data, or who asked for that data, when they asked for it, etc. These are all kind of hard things to address, and I think there's a lot of work to do here yet. But it's one of the things that we have to think about when we're creating new origin backends. All right, and I also mentioned some things about health monitoring. So one of the things that the origin is responsible for doing is telling us, is this service even working? Are the clients who come and ask for data able to actually get the data or put the data that they're there to work with? So the origin is there to provide a service to clients on behalf of the data providers. What do we need to do to tell if that is functioning correctly? There are a few ways we do this in Pelican, and a few different levels at which we do this. The first is what we call director origin health tests or transfer tests. This is where the director tries to mimic a client by going to this origin and saying, I'm here to put a file, put an object, and then I'm going to try to read back that object. And if we succeed doing that end to end, then we know clearly the origin is able to interact with the object repository because we completed this cycle of putting and getting the object. There are some problems with that though, right? Because the director comes in to act as a client, but it doesn't necessarily behave in the same way that the clients actually using this origin might behave. So to try to round things out, we also have some built-in health monitoring inside the origin itself. So the origin will essentially leave the network, come back to itself, and do the same types of tests. This is imperfect. We actually do run into issues sometimes where these director origin or origin health tests, they all show up as green, but it turns out anyone who comes and asks for real data at that origin, they're going to encounter a failure. So we also have a little bit of work to think about how we can make that more robust. And then kind of this piece I covered earlier, the origin is there to do some I/O monitoring, make sure that it as a service is able to keep up with the requests it's getting. And if it starts to realize I'm getting overloaded, maybe it'll tell the federation to cool off. And if this namespace is supported by a different origin, go talk to that other origin instead of me because I'm too busy. And then again, one of the key takeaways of all these slides is that every single time we want to do this for a different object repository, it's kind of a different set of rules. And we have to think about what does it mean to do these for this specific technology. Okay, so I've talked a little bit now about what it takes to make an origin. My talk is actually supposed to be on the new origins that we've come up with, but I thought it would be difficult to talk for that about 20 minutes. So some of these are origin backends that we have talked about in the past, like the Globus and HTTPS origins. In the past, when we've talked about these, they've been partially supported origins. And by that I mean, if you call back to the table of all the different translations we had filled in some of those boxes, but not others. At this point though, Globus and HTTPS, we think they're pretty much production ready, and they more or less support the same things that the bread and butter POSIX origins that we run support. We've also done a little bit of extra work on the xroot origin. So this is for people who maybe have an xroot server running somewhere, not as a part of a Pelican federation, but they're interested in standing up a Pelican origin in front of it to maybe map namespaces or otherwise federate that as part of something like the OSDF. So those are kind of our two refinements. We're also working on a completely new type of origin that if you're interested in asking specific details of, I'll point you to Brian Bockelman. He knows a lot more about this than I do at this point. But it's to allow access to things like HPC systems where there's no necessary API for accessing data. So we do this by establishing an SSH connection and then using that SSH connection for the movement of data. And then finally, these aren't really necessarily supporting new technologies, but they're a fundamental shift in the way we support existing object repositories. And that is rethinking the overall architecture of how we use xrootd. So we've started to tinker with, and especially the last 6 months, what would it take for the Pelican project to own that data movement by working on POSIX v2 origin that is pure Go. And then we're also now working on Globus v2, HTTPS v2, and S3 v2. Those are coming soon. I don't think they've been merged into the code base, but POSIX v2 is there and kind of ready to try if you're a brave soul and are interested in living in an xrootd-free Pelican world. Okay, so I'm running short on time. I wanted to talk a little bit now about caches, and I'm hoping to tie this back to origins in just a second. So in the typical Pelican setup, there is an object store that has the source of data, so some object named foo, and the client comes through a cache, goes to the object store, pulls the data through the origin, and it makes a copy of foo. Now the client has a copy of foo as well. A few years ago, we started thinking about how can we add more caching to this setup. So we worked on something that we called the local cache. And this is meant to be a cache that serves kind of the cluster or data center level of client. It's meant to run in one place, and it provides copies of data for clients that might run in a cluster or a data center. Then we decided, okay, well, we need caching for institutions, right? Whatever you mean by institution, maybe these are the Legos of the world, et cetera. And so we worked on this feature called the site local cache. So this is essentially a private cache that somebody like Lego can come and use. It serves Lego clients, and it can make copies of the data. And maybe it's not willing to serve other namespace data, but it'll serve Lego data. And this lets Lego kind of choose how they want to manage their own storage. Okay, so for the astute observer in the audience, what's missing from this picture? We're adding caching to the origins now too, essentially. So origins themselves can now store copies of the data. We're trialing this, I think, in S3 origins. And I think maybe the natural question is, why do this? What do we need all this caching for? What benefit do we have by storing copies of the data at the origin? I think maybe one of the key things that I should call out here is that in a lot of our actual deployments, the origin and the object repository don't live together. So the storage, the actual disks holding the data here in the object store are completely separated from where the origin actually runs. And generally, we assume the origin probably doesn't have enough of its own disk to hold all of the object store's data, but we're maybe willing to make copies of it. And I think the reason we have this kind of gradient of caching is that these different caches are there to serve different types of users. So on this end, the caching is meant to serve the local clients who are showing up to actually use the data so that they can get a hold of the data more reliably, maybe quicker if it's in the same data center and it doesn't need to be transferred over a network. Whereas toward this end of the spectrum, this caching is meant to protect the object stores. So if the origin stores the 10 most popular objects in its local disk, we don't have to go and ask the object store for those 10 objects because they're already held by the origin. So there's a spectrum here, and the key takeaway is we're kind of now thinking of adding caching to the origins. So that's everything I had to get through. I'm open to questions about new backends, backends that you'd all love to see us work on, or backends that are insufficient and you'd like to see us put more effort into, whatever it is.
I had a question with regard. So there is still expert D stuff happening underneath the covers of the origin, but it seems like with the Pelican client, you don't allow for expert D streaming of files, which is the main reason that one would ever use expert D. So it's expected that legacy ways to stream files in OSDF, or I mean, as we used to do it, is still going to be available?
Yeah, so the Pelican client is not built to stream data.
Right.
But if you're willing to come talk to this xroot origin that is speaking HTTP, we'll still let you stream partial data or ask for specific chunks of an object at offsets and things like that. And I think we plan on continuing to support that.
I mean, we've historically done that through CVMFS and the osgstorage.org repositories, and we're still quite dependent on that. So
I think you're mistaking two things that often gets conflated with xroot D. There's xroot D, the piece of software, and then let's call it xroot, the protocol. You use HTTP protocol for all the cases you mentioned there to stream data, and that certainly doesn't change at any point. And so for the example you just gave, CVMFS, it's never
There's no windows in the
xroot support the protocol. It's always been HTTP. So here you can still do streaming. This is something that particularly, for example, NCAR does quite a bit of, but it does that with the HTTP protocol. And then the difference between HTTP streaming and the xroot streaming gets really, really into the weeds then.
I don't want to take the further time in the thing to do it now, but you did not answer my question with the answer I thought I wanted. So we'll talk later.
Yeah. We'll grab a coffee break.
Oh, I was wondering, is there any work done on caching on the other side, closer to the Condor EPs?
Yeah, so I know Condor is working on its own feature called Slot Zero, which is kind of maybe an EP-based cache. I think Todd Miller is the person to ask about that for more details. This local cache idea, in some ways, was a competitor of the Slot Zero idea. And I think local cache kind of lost out. But we are still thinking about what it means to have caching at the data center or execution point layer. It just might not necessarily be something we implement in Pelican. It might be something we work on in Condor.
I think there is a difference. Slot Zero is managed by the AP. It's not clear to me, Adain, in this scheme, who is managing the local cache, who allocates the space for the local cache. So it looks nice, but in my book, it's far from being fully baked. So, but since I have the mic, are there any thoughts of what happens if the local cache is on a shared file system? Because you're showing me the client there, and it's not clear to me whether the client is sitting at a web browser or it's an application.
Yeah.
And which is also, but how would it look if any of these caches is on a shared file system accessible to the client?
So, Brian, maybe you can step in here. I think the local cache is part of that shared file system. And in this case, I'll specify the client I'm thinking of here is not a web browser. It is more the Pelican plugin running as a part of a Condor job.
Okay, so the assumption here is that you create a copy of foo, but you may only need a symbolic link to foo.
Exactly. Yep.
So where does it and again, you know how much I like the term caching, because I don't know, can I pin, can I keep things, can I manage it?
At the moment, no. So it is, I think,
I
purely
know,
caching.
I know. But that's another element of this discussion that we have to clean up.
Yeah, what I was going to mention is, this slide is exactly why we get in trouble for the word cache, because I think in a lot of these cases, conceptually, it's harder to think of it as a cache than a staging device. Like the example at the origin, I at least, I know we didn't label here this picture. I think of it as a lot more as staging as well on all the way to the left. So I would say, actually, Ron, you asked that. I think the answer to your question happens to be Todd's presentation tomorrow. So in terms of a sales pitch, see us tomorrow.
So
Come in
just
bright and early.
just from the Zoom room, so speaking of all this caching, do we have hit rate stats on the different caches?
I think we do have statistics that we record as a part of Condor job records. I'm not sure who the best person to ask if you're interested in those hit rates is. I know last year Frank gave a talk that covered some of the hit rates, and it was something like upwards of 95%. So if I recall, it's a lot of data used in the OSDF are heavily reused.
Another comment about caching at the origin. I feel that the whole system should be aware of the limited capacity of the object store. So if I have a limited number of transfers I'm willing to do in my object store, so the more I stage in the different layers, the more application I can run concurrently against data coming from there, if I can do reuse.
Right.
So whether I keep it at the origin or I keep it anywhere in the hierarchy, it may be in my interest not to hit the limit that is enforced by the origin vis-a-vis the object store.
Yeah, and I think one of the things we have to work more on is the object store being able to say to the origin, here are my limits.
Yes, but I want to make sure that this responsibility in terms of allocating and retaining and all this is throughout the hierarchy and not, I don't care when I'm at the top. what are the constraints of the origin? Because I will ask a different question. How do I know as a potential client what is the constraint of the object store? Because I want to plan my execution based on what I can expect to get there.
All right, thank you.
Thank you, Justin.